Ladies and gentlemen, it is our privilege to welcome today's distinguished speaker, Professor Aparajita Ojha ma'am, a renowned academician and researcher in the fields of artificial intelligence, deep learning, and computer vision. Currently, a professor of computer science and engineering at IIITDMJ, Professor Ojha brings over 38 years of teaching and research experience, including a tenure as the director of IIITDMJ. She holds a PhD in mathematical sciences and has made
Oh, Gaurav.
significant contribution to deep learning.
Hello, Gaurav.
Second,
You have already introduced, so no need to introduce again. Thank you so very much. Thank you
okay,
so
ma'am. Okay,
much.
ma'am. Over to you, ma'am. Sure.
Thank you. Thank you. So, participants, very good morning to all of you. And I'm sure that you're having an exciting time learning new things and so many speakers who have given diverse uh, lectures and lab sessions they've taken in diverse areas. From in this week, we are going to um, discuss about how we can implement these deep learning ideas for different like problem solving in different domains, right? So I would like to specifically tell you that today is the last date. You have to submit by today the what is your project topic, what is the objective, what are the deliverables, and let me just copy from here something, or maybe you can see from my. I will share the screen. This is screen. I got this information just now because you have been already given this information. So first of all, for any problem solving, what is the primary objective, right? Once you define the primary objectives, what do you want to deliver? So you will have to also make a presentation summarizing what you want to do in this project, right? So with a link to your code, because you know that there are wonderful opportunities for people who are top in this list of who attend regularly and who can also make a good presentation. They can successfully execute the project. Then there are internship opportunities, and then you will have to do, as I told, project submission by today, and sorry, topic submission by today. And by Thursday, we will expect you to also submit the project presentation along with the line of your codes. Uh, Tracks, you may be knowing that there are various tracks that you can think of in applying deep learning, like computer vision, then remote sensing, healthcare, you can choose in agriculture, and you can also use security. uh, Natural language processing is also booming industry, so you can think about that as well. There are several areas of healthcare. There are several areas of for society, for example, speech recognition, and then you can also think of financial market, how forecasting and fraud detection can be done. How can we improve the lives of people by applying deep learning in for smart cities and urban analytics? And uh, in supply chain management also, a lot of optimization can be done, and how deep learning plays an important role. You can apply that. So these topics we have discussed in different lectures. Some of these topics have already been covered. Today, I would like to tell you two important topics on which my students have done research, and I would like to uh, give you some idea of two domains. Although there are a lot of domains in which my PhD students have worked, but let me specifically tell. two domains. All right, so in which my undergraduate students are also doing some work, and definitely PhD students have done excellent work in these areas. So projects on deep learning applications. We are talking about deep learning applications, not specifically on advancements of deep learning, right? So in this session, main steps in DL-based R&D projects, project topics and discussions. These are important directions that these are two important things. So steps in DL-based projects, all of you know. How should we start? Can somebody tell? What is the first step of DL-based project? Can somebody tell? Write on the chat box. What will be the first step in DL-based projects? Choose a data set, input and data. That's title of the project. Good. Problem statement. Yes. What Nitish says is right. Choose a problem. You have so many problems around you. Unless you know what are the problems and where I want to devise a solution, uh, there is no point of using deep learning, right? So data set is secondary. It is very important component, but first is the problem statement, right? So what is the problem definition? You will have to actually define what is your research objective or what is the objective of the project. Is it a classification based problem? Is it a detection based problem? It is a generation based problem. What kind of problem are you trying to solve? So you have to identify gaps in the existing works that we call literature. And then you can define your research questions. So for example, the problem can be data scarcity or data imbalance in some cases in training deep learning. That can also be a problem. Problem can be identifying diseases in plants. The problem can be identifying abnormal activities. Problem can be identifying the top trends in market. It can be any problem, right? Then step two can be you actually find out, pinpoint what exactly is like what is the progress, current progress in this. So existing methods, and then you have data sets, because without data sets, AI, current AI methods cannot work, cannot be trained. So you will have to look at the existing methods. For example, if it is the problem of market trends, so are there existing methods that have solved this problem of finding out the trends in a specific market, whether it is Boolean market or it is the market in car industry? So are there such existing methods? And if there exist such methods, what data sets they have used to identify the problems and to find out the trends? So we will be understanding the DL models that are used here, right? And what are their merits and what are their weaknesses, right? Sometimes exactly that problem you may not be finding many works, but in related problems you can find out similar works. So third, once you are very sure that yes, there are existing methods that have found out, that have used this data set 1, data set 2, data set 2, 3. So let us try to either download those data set, or in some cases you may have to collect data. Suppose you're trying to solve a local problem of unemployment around my neighborhood, in my neighborhood. So in that case, you'll have to collect data, and you'll also be required to pre-process data. So there are methods which we have discussed in the past. So first of all, we collect, there can be structured or unstructured data. You will be required to clean data. So suppose I take n number of pictures of an area to find out whether this area is full of trees, or there is urbanization, or there is organized type of arrangement in an urban planning, in an urban setup, or there is an urban unorganized development. For all these, you'll be clicking several pictures, and then some of the pictures may be similar, some of the pictures may be blurred. So clean data. Then you have already done some coding, so you know how to normalize data. Sometimes you need to augment data. If the data set is imbalanced or the data set is very small, you can add more data by using several augmentation methods, including generative AI. And then once you have collected the data, pre-processed it, cleaned it, normalized it, everything is done, then what you will do, you will be dividing the data into small chunks, like chunks which may not be small. Suppose the data is very large size. Suppose the data is, say, 1,20,000 samples. What you will do? For large number of data samples, normally we take very large size of, say you take 95% or 98%, you can take as training data, right? And 2% you can consider as test data for very large size data. If within this training data, you can further split into train validation also, pure training, and then validation. But if it is a middle size, then sometimes we use 80-20, sometimes we use 70. If it is a very small data, then 70-30 also. So depending on the data size, you divide it into training, validation, and test set. Then after that, what do? We select models, right? And the training methods also. So what we will do is that once you have identified the problem, you have got the data is ready. Now, which model architecture should we choose? There can be purely CNN, purely LSTM, or they can be, you can customize it as per your requirement. So you will have to think of a DL architecture, which is having these units like convolutional layers can be a unit, LSTM can be a unit, or transformer units can be there. Then we also define the loss function. What do we want to minimize, right? If it is a minimization of mean square error, or it is the cross entropy loss that we are taking, or it is a combination of different loss values. And then you will also be required to define the optimizers, other hyperparameters, and how are you going to train the model, right? It can be fine-tuning an existing model, or it can be training from scratch, different types of training methodologies you will be using. Now, then once that is done, then you will be training the model on what data? Training data. And you will keep on evaluating it on validation set. And this is normally done, suppose you are getting good results in training, not so good results in validation. You would like to tune the hyperparameters of the model. Then we go to model evaluation. Once you are happy with training and validation performance, then you go to model evaluation. So suppose it is a classification problem, then we take accuracy, precision, recall, F1 score, confusion matrix. If it is a regression problem, you may take mean square error or other types of error functions that are defined. If it is a problem of generation. Then for generative models also different types of measures are defined. Then finally, so once everything is done, because you were starting with a problem, so you would like to deploy the model to solve the problem. Training, testing is done, everything is done. So for deploying the model, what people in industry do generally, they compress model by pruning models or knowledge distillation methods that you have heard of. So pruning model means basically what happens that, that suppose the model is a large, is having several million parameters, and then it is having floating point operations also. So what we do is that we try to figure out which connections are less important, which are given less weightage, and which neurons are less important in making decisions. Accordingly, you will cut the size of the model. This is known as a pruning method. There are existing library in PyTorch also. You'll find out some library functions. Similarly, knowledge distillation. You have heard that if it is the knowledge was like there is a very big model, you would like to transfer that knowledge to a smaller model relatively with the same level of performance, that a similar level of performance that you expect. So then we convert model to TensorFlow Lite or Torch script so that it becomes like easy to handle. And then what we do, we deploy model on a mobile app or a web app, an edge device, anywhere you can do that. So that is the complete cycle of creating and like creating a deep learning model. So I go back now. These 3 steps: problem definition, then you background study you need to perform, then you also find out what are, just don't look at 1 or 2 data sets. If there are 10 data sets available, please take all 10 data sets, because the same model may perform differently on different data sets. And then model selection, and then training, then evaluation, and then finally deployment. So these are 6 steps which are must. Okay. So I would like to also discuss some project topics. Please feel free in asking questions, because this is an important domain, important phase of your summer school, where you learn to independently work on a project. Okay. So I would like to tell something about the projects on which we have been doing some research. One is environmental safety, where say wildfire smoke detection can be one topic, because every now and then you must have heard about fire broke out in some jungle. So this wildfire or detection or smoke detection can be a useful area of research. You can also think of what is happening, floods everywhere, the moment 1 or 2 showers Delhi receives or Bombay receives, it suddenly floods. Why this is happening? Is there some kind of unorganized urbanization? What kind of developments that have taken place? So these are some examples I'm giving you of problems related to environment. So why I'm telling you these 2 topics, because on both these topics, our undergraduate students are also doing research, right? And the third topic that is also quite interesting is finding out ocean plastics, which I gave an idea to one of my students, and she's working on that. Okay. The second problem is like agriculture. See, when we talk about developments in India and AI for implementation in India, our problems And our application domains are unique in the sense that there are many areas in which India has a different type of uh, mm, uh, like works, different type of society, different type of livelihood, and many other things that are there. And agriculture is a one of the prime, uh, we can say that the domain segment where lot of people, around, it is said that around 70% of people depend on agriculture for their livelihood. So agriculture can be a very good domain where crop monitoring and plant disease detection can be one area. We can also think of, with respect to agriculture, there are many other things, livestock, many things, counting of trees. There are so many things that are there. Well, also in healthcare, India has a different challenge because not only sophistication is required in terms of technologies, but also how to reach the unreached, how we can provide an affordable solution, healthcare solution to a person who is sitting in a remote area or who is sitting in urban area, but it is not able to pay enough. So there are several areas where you can think of applying this deep learning methods. Some of our students have worked on, say, diabetic retinopathy, because a lot of people, only when they lose vision, they realize that they're having some kind of retinopathy, and that happens very late and that is irrecoverable. Therefore, early detection of any diabetic retinopathy is important. So we can think of devising solutions that can be low cost solution, right? So Soumyadeep Dev is asking, could you recommend where to look for data sets in the areas that you are discussing? I will be coming to that. Data sets, when we say that the data sets are increasing in number, people are sharing their data. We can also, once you gain access to those data, you can see that that is not enough. So I seek your inputs and your valuable contribution in data generation as well. So for data, you will have to, as I told you, that we will have to look at the literature, and the literature only tells what kind of data sets are available. And Juhi Faridi is asking that biomedical signal like ECG, EMG, or MRI based work will also come under healthcare. Yes, that will also come under healthcare. I'm telling some areas in which our students have worked. They have also worked on EEG, ECG signals. They have also worked on MRI data, many other areas in which they have worked. These are only some examples. Now, in data security, we have worked on digital watermarking, steganography, and then of late, our two, three students are also working on network IoT systems security. So everywhere data is important. Now, when we talk about models, the current models, it has been found that they are very good, but sometimes when they fail, we are unable to understand how you are getting these results. And so when they should fail and what is the reason of failure is not known. So what happens that one would like to have more explainable AI. So you can think of working in XAI in specific domains, or you can think of working on problems related to XAI. unexplained, like black box kind of AI deep learning models. For a specific network architecture, can you devise some new methods? Can you analyze those methods, right? Failure is not always in terms of less accuracy. Data for AI is, somebody was asking, where do we get data? So we can work on scarcity of data. We can work on bias. What are the data biases? Then ethnicity, because if it is a healthcare data or the social related to social security or social analytics, then ethnicity is important. Well, not only that data is scarce in some domains, what happens that there is a imbalance also. So for example, for normal category, we go to a doctor only when we have some problem. So blood samples can be normal, very small number, and blood samples can be abnormal, a very large number, right? So that is also possible. Some question is floated here. My background is electrical renewable energy. So can I do the project related to my field? Anybody can do a project in his field. There are a lot of different domains in which deep learning applications exist. You can work in your domain. When we say bias, so bias can be with respect to, for example, can be language. English language is dominating, so there can be language related bias, there can be region related bias. There are several types of bias can be there in data. So we have to work, you can work on these areas as well. Okay, so for environmental safety, there are several areas in which you can work. One of the areas in which my students worked is lightweight, have been, they're working in fact. Um, how do we design lightweight models for real-time fire smoke detection on edge computing? So idea is that can we deploy them on, say, lighthouses where we have very edge devices are there installed on that, mounted on lighthouses. Can we think of having such, or on drone devices, or on any other device? Then the work can also be done on fire and smoke detection and localization in satellite images. Suppose the satellite, we are doing surveillance through satellite inputs, and if something occurs at a place in a forest, then what happens, that current problem is that it is very late, that by the time we know that yes, there is a fire, that is fire incident has occurred, it is very late. So can we think of devising a solution that not only that you detect that there is a fire, some fire incidence is there, but actually you're also able to locate where exactly is fire. So, so some of these slides are taken from the presentation of my student, PhD student Shubhangi Chaturvedi, who is working in this area. She's going to defend her PhD in 2 days from now, on 11th of June. So as we found that fire is among the most common forms of hazard. And what happens that it is unplanned, uncontrolled, and also unpredictable. So it can happen that if there are, you can find that the dryness in forest areas can lead to fire, but sometimes human activity can also lead to fire. So it is something very unpredictable. You'll be, I mean, if you see the figures, it is so much devastating that in the year 2023 alone, global wildfire generated around 2,170 megatons of carbon emission. So it is actually very bringing adverse effect on the environment. So Canadian wildfire actually amounted to 22% of the total 2170. So you can imagine the life of people around that place. And these wildfire have caused a lot of, say, total loss of 12 million acres of tree cover. 12 million acres, an increase of about 24% from previous records. So many researchers have done is that normally what happens that you see from a distance some smoke is coming out. That means there's some fire, right? Because smoke is an early sign of fire, which is visible from a long distance. So therefore, vision-based methods can be used. They are very commonly used in identifying, mitigating, controlling fire incidents. So these are very common methods. So we also adapted to vision-based methods. So you can see that this is an example of like where vision-based techniques can be used. Here it is a wildfire where also vision-based techniques can be used. Any questions you have in your mind before I proceed? So I am telling you about the areas in which I have been working, and my students have completed their PhD or they're doing PhD. So what are the challenges in fire smoke detection? Okay. One very important challenge is that they're visually, sometimes, fire smoke is visually similar to other objects, like the one you see here and this one. Like, for us, it is easy to understand that this is not smoke, but if you see, both of them are quite similar, right? Something here, it is very similar. It is very similar, right? So, how do we explain? How do we expect the system will learn and to differentiate between fire smoke and similar objects like clouds? The second is that weather condition. Sometimes weather condition, it can be hazy, it can be dark, it can be sunny. So weather conditions like foggy or hazy environment, they make it really difficult to identify smoke, as you can see here. The third is like fire smoke recognition in early stages is very challenging because when it is, think of a satellite image, very small amount of smoke you will find. So it is very challenging. It will look something similar to this, so something similar to this. So it is very challenging, right? And there is another problem with the fire smoke detection methods, and that problem is that because of similar objects, because of weather conditions, because of many other things, sometimes non-fire is also considered as a fire incident. So there's high false alarm rate due to these reasons. And if there is a high false alarm rate, what will happen? In that case, you will not be able to see whenever there's a fire alarm, there's a whole team of fire management people who will be alerted, evacuation of things, then people will be they will be rushing to the spot, and then they will find that there's no alarm, there's no fire. So that is unnecessarily wasting the energy and resources. Now, because of the data scarcity in the field, as somebody was asking that how do we get data? If you find that there is a scarcity in your field, think of alternatives. What alternatives are there? So we created a IIITDMJ smoke data set Here we utilize the we utilize one undergraduate student, Chandravanshi Shubham Arun. So this work was primarily done by Shubhangi and Arun for data collection. And then what they did was they created from Modi's satellite, they created, fetched images which were from normal and foggy environmental conditions also. And they were, in the Modi satellite, non-smoke were, say, 6,820 images. Then smoky images were 4,784 images. So you can see that how difficult it becomes. Like, this is something like cloud. This is also like cloud. So we as humans are able to differentiate, but think of computers or programs. So total of 23,644 images were captured, and then they were all labeled, pre-processed, and this data set is now available publicly. So you can use this data set for creating your own model. Then we also considered publicly available data sets. There were 3 other data sets. These 2 are, you can see that these are CCTV or general mobile camera images. And this was a satellite. So this is also a very different type of data set. You can see a lot of challenges are there in this satellite data set. So what is happening? CNNs were initially considered as popular solutions, and many solutions are proposed. But later, with the introduction of vision transformer in the field of computer vision, new models have also been created. So, but initial methods were mostly heavy in terms of computational requirement and memory requirements. The current trend is to develop lightweight models. We get 2 benefits. One is that the memory demand is low, computational demand is low. And second is that they are quickly trained. I mean, you can train them quickly because not many parameters are to be tuned. Then one thing that is important in not only in Indian scenario, but also in the Western and other in the Western world and in this Far East, Australia, New Zealand, there also a lot of forests are there. And so IoT-based applications for fire monitoring and or industrial monitoring is specifically in the context of India is less common. And this is also not very well adopted in the developed countries. When we build a model, suppose it is a classification model, okay? So let me ask you a question. It is a classification model. This model is being trained on a data set. Say data set. Data set is there, which is segmented into, say, training, validation, and then test, right? And this data set is, say, publicly available data set, or you have collected data set. And on, say, training, the accuracy is, say, 98%. On validation also, you find 97%. And on test, you find 99%. You're very happy, right? Do you think that the model will actually work in the real world scenario with the same level of accuracy or not? What is your answer to this question? I have trained it on using, say, one data set, two data set, 10 data sets. Will it work in another, on another data set or in another domain? So it may not perform with the accuracy, it is saying in 98, not guarantee that it will work with all real world data. Soumyadeep is saying, then Isak Kir, Kirj, Isak Ranjam Rajan is saying noise may be an issue. No, I suppose even if I remove noise, probably not. No, it may not. So Vijeta, can you just tell why you say no? So Rajesh Kumar is saying if it is similar so that it can perform. Rudra Chauhan is saying that no, same accuracy will not get. Accuracy will be an issue. I agree with you. I agree with you. My question to Vijeta, she's saying no. I just wanted to know why. Because of accuracy? Why because of accuracy? Accuracy it is showing good. Why it will happen? Can somebody tell? Can somebody unmute? Gaurav, can they unmute? Is it possible that they unmute? If you raise your hand, we will unmute you. Please unmute yourself.
Yes, ma'am, they can unmute.
Okay. So Vijeta, can you please tell what could be the reason? So feature extraction, what feature extraction, Lakanlal? Okay, so many of you are saying it may not be doing. I agree with you. And somebody said if data is similar, then probably it will do. I agree with you as well. Now, because what happens that if suppose this is the data distribution from where I have taken data, I suppose this is the data distribution from where I have taken data. And suppose I have taken data mostly from here, this population, and I have not considered this population. So even if the data is from the same population, same distribution, but I have not considered a fair like distribution of data. So what will happen that even if I choose the same data distribution from where I'm taking out the samples, the model may not perform well because it has not learned the features appropriately. So generalizability of DL model is not studied thoroughly in many domains, including satellite image-based fire smoke detection. So what does that mean, generalizability? What we can do is that we can train the model on one data set, right, and test it on another data, right? So this is D1, data set 1, tested on D2, right? So on this test set, suppose I choose this test set of data, test subset of data, right? So here what I will do is that I will train, test, validate, everything is done here. Once it is done, I will check what is its performance on data set 2. If even if the two data sets are similar nature, that both are say plant disease detection data set, let us see what is the performance of the state-of-the-art model. And that could be an important project for you in any domain. I'm giving you a case study of this domain. Finally, one more important part is like small size smoke. I told you that early catching of smoke can help us control the fire. So that is a very challenging job. And one more thing, that is the high false alarm rate is a concern for applicability of these models, because if it is not performing well, it is every time giving a high like false alarm. then the people will think like, that it is not working properly, and they will ignore any actual real alarm that is coming. So work done. We have worked on false alarm rate reduction. We have worked on model size reduction. We have worked on creating models that can work in adverse condition. So Isa Kiranjan is asking, can you explain what is a small size? That is what I'm telling you. That suppose in satellite images, you have images very large. Suppose normally images are covering large areas in satellite images, right? And smoke occurs here somewhere in forest. Forest is this area, it's forest. Smoke occurs here. So in the pixel, in the entire image, suppose this is covered only say 1% of the total image. So this is a small sized, right? Similarly, in the natural scene, and you have taken a scene from your motorbike, riding a motorbike, this is a road scene, and somewhere in the, like very far, there is a smoke that is appearing. That can be very small. So these are all examples of small smoke. So we have worked on reducing the false alarm rate, and under the condition that the fog can be foggy, or it can be cloudy, or it can be hurricane. Even in under these conditions it can happen, right? Then we have worked on reducing the memory requirement and computational requirement. That means developing lightweight models. We have also analyzed the real time. What is the real time performance? If I deploy it on edge device, for example, on a drone, we have seen making use of a Jetson Nano as the like your computing device. So we let's see that how the current models performs in terms of real-time performance and generalizability, right? So these are some of the works which are important in the context of data set. I told you that we also collected. So my request to all of you is that create data. It's important that you generate data by collecting data and by labeling data. It is very important because India is underrepresented in terms of data. We do not have data in any specific domain. You will find that India's data of India, that presence of the data of India is very, very, very low as compared to the population that we have and the size of India. So collected videos with using satellite cameras, then labeled the data. We used videos and images. Then we also created a model that was very simple, very, very simple. Just 0.4 million parameters and 0.17 gigaflops, billions of operations per second. And so model size was primary aim when we tried creating this. And my student Shubhangi led this research in terms of development. Uh, so somebody is asking, Swapnil Fagade is asking about, what about campfires? The smoke is not small enough to ignore, but it is not wildfire. So if you campfire, what happens that campfire in jungle area can also be requires alert. So those campfires should be properly monitored so that they do not uh, go unnoticed and they start spreading. So all these things have to be also taken care of. So Then so this smoke VIT was a very simple model, but very small size. Then we created like another important model. We call it multi-attention interlaced network, MAIN. MAIN means multi-attention interlaced network. As you can see that here, the model performed well on satellite fire smoke dataset, and it also had just 0.7 million parameters with zero point 0.2 gigaflops, millions of operations per second. What is the role of vision transformer here? Vision transformers are always good for anything that has to do with computer vision. So vision transformers are very important here. I will let you know how we have used it. Then the proposed model for model size. So you can see that the interpretability, we were actually working on interpretability also. Somehow that interpretability is not obtained as per the expectation. Then we work on small size smoke and keeping it lightweight.
SEMrush's AI toolkit tracks how AI sees you and the competition, so you can take control of your AI visibility. Impress? Explore all SEMrush toolkits and get what you...
Gaurav, you session
Hi.
chair.
What's your name and where are you from? My name is Mark and I'm from North London. Yeah.
Sorry, ma'am, for the inconvenience, ma'am.
Six. Who have you brought with you
What
today?
you can
My
do is
wife.
that you can
She's
mute
somewhere in the
all.
audience.
Please
Brilliant.
use this.
My daughter is here, but she's only 2 years old.
Yes, ma'am. Please carry on.
No. So what you can do is that mute all and do not allow them to unmute themselves. They can raise their hands. This you do every session, right? So that will be because people here, some people do not have the uh, this is known as digital literacy or digital ethics. We must also train them on this. So somebody is not attending, he is attending some other thing and is just logging on. That is not correct. That is known as digital ethics, right? And so remain mute when you are attending, and all these things are part of digital ethics. Okay, so we worked on several things. So let us look at the overall smoke detection system. What happens that we start with data collection, then data you will be, once data collection processing is done, pre-processing is done, you split the data, train test validation, and then after that you do like, actually it is a other way around. We first pre-process kind of thing, and then we do model training and then testing, then you deploy them. That is the idea, right? So this is one of the first models that was created by Shubhangi and her colleagues, Purnima also. So what we did, like we took a simple image, downsized to 224 cross 224 cross 3, and then we took some layers, mind you, we took some layers of pre-trained mobile net V2 models, not the full model, but because we wanted to make it lightweight. So it was a pre-trained model. So it has got some knowledge from a different domain, and that saved model was initialized, and then we fine-tuned it, right? And then what we did was that we used two parallel VIT. Somebody was asking what is the role of vision transformer here. We took parallel VIT models here, and these parallel VIT models were taken with different patch size. Then what we did, so we extracted features at different scales and then fused them, right? Then we fused them, and then we further refined those features to finally classify images into four categories: smoke, smoke with fog, non-smoke, and non-smoke with fog. That was the idea. So initial feature extraction is done by a convolution layer. Remember that in the vision transformer paper also, they have written that if you use a feature, if you use some CNN, a small, like some layers of CNN, then that helps vision transformer in better understanding the features, right? So it is always better that we apply some initial CNN layers, and then this is what our experience says. You can directly apply CNN vision transformer, but we found that when we apply one or two layers, one or two blocks of CNN layers, then it does well. So these two parallel networks are same, just like input is different. Yes. So two parallel transformers, first path uses 7 patch size, the other path uses 9 patch size, identically doing it, but the patch size is different. And we performed evaluation initially on only CCTV camera data set, and they were giving the best results, 7 and 9 patches size, and therefore we proceeded with that. And that helped us in finding out that compared to many other works, this model was performing much better on these data sets. And you can see here the parameters are also quite reasonably good as compared to other models. And these are all, most of the models appeared in very good journals. We also tried finding out, making use of TSNE plot, which is a method of clustering the features and then projecting them on a 2D 2D plane. So you can see that this is the last column is our model's performance on these, say, Khan data set, He data set, triple smoke, and USTC smoke data set. What does this say? This tells that the model is able to cluster similar features of the same class very compactly. So it is able to understand different classes and very well, and it is able to very well cluster those classes into different like groups of clusters. So TSNE plots tell what is the distinctive feature extraction capability of your model. Then we also tried finding out what is its cross data, how generalizable the model is. Suppose I train on Khan data set and test on He data set, then it was not performing. Like none of the models was performing so well, but our model also did not perform well. Best was this Muhammad et al. And Khan et al. I go back for this. So Khan et al., you can see the number of parameters is huge. Although Muhammad et al.'s parameters are higher than us, so that could be the reason. But still, we wanted to do it with lightweight. How we can do that, we were trying to find out. So yes, Juhi Faridi, if you have a very large feature space also, that also is projected to 2D using some clustering method, K-means or anything. So apply TSN. So here you can see that if we trained on He dataset, He et al., and tested on Khan et al., then this is the result. The purpose of telling you all these is, purpose of telling you all this is to tell you that you actually need to follow all these steps: data set collection, pre-processing, then think of the model, For this, you have to do evaluation study also. Think of some primary, like existing, when you see existing works, so you will have some idea, okay, this person has applied this type of model. So can we think of applying some novelty, having some novelty even more in our models, so that the problem can be solved in a much better way. So we tried everything. We tried with, we also applied, we did ablation study. So this gave the better results. And then we also tested its performance, compared its performance with several other models, existing models. Then we also checked cross data performance. All these things were done. Then we tried to find, also find out how explainable this model is. It is a vision transformer model. So remember that we first flatten the images. These input is flattened, and then it is processed through the vision transformer. So in some way, we can say that the overall structure, although it captures global features, but overall structure is in some way uh, processed in such a way that getting back the um, the original type of image, like if I look at the one correspondence between the input and the output, or the correlation between the input image and the output volume, in human eyes, in terms of human eyes, it is difficult to figure out. So Sangeeta Trehan is raising hand. What is your question? Can you please write on the chat box, or you want to ask something?
Yes, ma'am. Thank you. I think I have been unmuted, so I can ask you verbally. Yeah. So just wanted you to throw some light on that when you were showing the architecture and the process, like initial feature extraction was done using CNNs, and then two visual encoders with different patch sizes were introduced. So that was the final architecture that you guys used. So I just wanted you to throw some light on how you arrived at that architecture. Could you just... Was it like through trial and error? Did you try different variants? And so that would be very helpful.
Yeah, Sangeeta, very good question you have asked. In fact, when we do literature survey, that is the second step after you arrive at a problem, you look at existing methods. So we found that most of the methods were based on pre-trained architectures, very heavy, like efficient net, VGG, all those were very heavy. And when we think of deploying them on drone, it was next to impossible. You cannot, on drone, we have very limited memory where these things can be detected. So we initially started with lightweight, like CNN models. So CNNs are one of the best feature extractors. We tried them. So lightweight models were existing, and then we also compared with vision transformer, because vision transformers had already uh, been shown good performance. So we parallelly tried with vision transformer first, just 2 units of vision transformer, 3 units, 4. So this ablation study was done with CNN and vision transformer, and then we uh, figured out that combination of CNN, and then if you reverse it, if we were first starting with just vision transformer, we were not getting good results. So we first, then we also studied the paper, and they have also mentioned that if in case of VIT, if some feature extraction method is applied prior to giving it to vision transformer, then that will help. So we used CNN, and because pre-trained architectures will help us in suddenly boosting the performance, and therefore we started with pre-trained. So this was a thought process. after a lot of experimentation, a review of the existing literature, our goal was to introduce lightweight models. By that time, of course, the lightweight models existed in different domains, but we have created, I should say, ultra lightweight models here. Thank you, Sangeeta. I think I have answered your question. So then we talked, then once it was done, because models, false alarm rate is very important in the domain of smoke detection. So we wanted to know if suppose, not only that the prediction is given that here is probably, model says that I'm 98% confident that there is a fire smoke here, but it also is able to tell the regions exactly, making use of some GradCam or other method. Okay, Sangeeta, no problem. So then you can see that it was in this case, in case of model explainability, our model was not doing so well. Other models are also not doing so well, as you can see. So we are talking of best models. None of the models are doing well in terms of explainability. By explainability in GradCam, I mean that if suppose fire is here or smoke is at some place like here, so the model should give this as a high, like red color, which is not happening in this case. So, and here you can see that it's showing red color here, whereas the smoke is here. So none of the models are able to identify in terms of GradCam. So we also compared our number of parameters. I think this I have already covered. So then we came out with a different crisscross attention. I take a break of 5 minutes and request you to please think about voice not audible. Am I not audible? Rajesh is saying voice not audible. Gaurav, am I audible?
Yes, ma'am. It's very audible.
Rajesh, you will have to uh, see what is your connection. Okay, Ashutosh. So we will take a 5 minutes break here. Just think about what is your domain, in which domain you would like to work, and uh, then so breaking from your side, Rajesh, we are sorry. This is what is happening in the current world. Anyway, so think about the problem in which you would like, domain in which you would like to work. If you can throw some here, like if you write on the chat box, then maybe I can request Gaurav to unmute you and so that you can talk about this. Before that, I will quickly tell you about this smoke detection model that we have somehow we were able to discover. Okay, thank you. Yes, I'm back. In fact, I wanted to give you some time to think about the topics in which you would like to have projects. So, but I did not receive this. In thinking time, I wanted to give you I have already given you some idea, but I've not received many suggestions. So, Smedha Chokda. This is a long project, and can you suggest some small project we can go for? I'm talking about Capstone Project. And for Capstone Project, you can think of just one, like think of just developing one model. Don't, if you once you develop a model, see, it's a not very long project. What you can do is that you can start with a very simple model and slowly increase the complexity of the model. And just you can see, you can make ablation study that for that model, what is the like how the model's performance increases with its complexity in terms of structure. So suppose you add some CNN layers, or you add the number of filters in some CNN layers. If you add transformer units, if multi-head attentions are taken more or less. So you can do ablation study for, take one data set, let it be say smoke detection data set, take one data set and try doing it for that data set, that what leads to a better accuracy or better precision or low false alarm rate, and are you able to achieve a false alarm rate that is better for complex model, but at the cost of what complexity? So you can like accuracy versus complexity, you can think of that. That is also a small project that you can do, right? These are, I'm telling you the process that we follow generally in creating a project and deploying it. So this model that we have created that I'm showing you here is actually deployed on an edge device, on a drone, and on using that we tested the model's performance, and based on the model's performance only we can say that these lightweight models are very suitable for edge AI. Now the current trend, as Professor in our original, like is our chief guest and guest of honor also discussed, that edge AI is a growing industry. So you will have to think of developing lightweight models. All right. So I hope Smedha Chokda, I mean, I've given you enough idea that you can start with very simple models and increase the complexity. See what happens to the accuracy, right, and other things. And then try this on, so this is one data set, and then try the model's performance on another data set. Anything, like I think within 3-4 days, within a week time, you will be able to make a good understanding of how models behavior varies with respect to complexity, and how its accuracy increases if you have a more refined structure, all these things. Okay. And mm, Rajesh Kumar, I'm so sorry you are facing some trouble with your internet. I hope you are now able to hear us properly. Can you give some insight on data security IoT based project? Yes, Shilpa, I can, like on cybersecurity, we can definitely give. So this, before I conclude about smoke detection problem or classification problem. Okay, Rajesh, thank you. So I wanted to just tell you that how do we arrive at model structure. Okay, okay, Rajesh. So now the model, now you can see the model structure is a little more complex. We have used MobileNet as the backbone network, but then we have split this into the features of this into two parts. In one part, we have used again the vision transformer, 4 layers. In another part also, we have used vision transformer, 4 layers. But what we have done is a crisscross connection. So these vision transformers are 4 layers, 4 units, but each is having a different patch size. Like one is 5, the other is 9, when we write, right? And then the features extracted from this vision transformer are passed through a layer which is similar to CBAM type of layer. We call it a different layer because we have slightly modified the attention module here. So we call it a crisscross attention module. And this is then what is happening, that this is coming from here and is going, sorry, it is the other way around. It is coming from the second layer and is going here. And similarly, you can see that it is coming from here. Just a minute, I'm just erasing. It is coming from this layer and is going to the final layer here. So you can see that there's some kind of crisscross connection that we've made. Why we made? Because you know that we already tested with 2 parallel models, right? Now we saw that there is something that is missing. So we thought that further attention is required. So between these two, we created attention. And then we again passed it through a classification layer: smoke, smoke with fog, non-smoke, not smoke with fog. And you can see that the components that are used in the network, which are written here. So Sangeeta Trehan is raising a hand. Can you please unmute her, Gaurav?
Yes, ma'am.
Thank you.
Yes, thank you. Ma'am, if you could throw some light on how these model modification and adding this, say, crisscross attention module, could you show or share the code so we can try to
This code,
compare?
yeah, actually, this paper is published in Industrial Informatics, IEEE Transaction Industrial Informatics.
But ma'am, usually in the published papers, the code is not completely shared, no? So if there is some Google Colab notebook or
We have an
something.
we have an image and vision engineering GitHub page where you can find most of the things. Like this data set is also available, and it has so everything is available.
Ma'am,
Now,
can you please share the GitHub link in the chat box or something?
right now, I don't, I mean, definitely I'll share with Dr. Rakesh Sanodia, and he will share with participants. Right now, I don't have that. Mostly my students maintain that GitHub page. So we'll definitely share with you, Sangeeta ji.
Sure. Dr. Rakesh, we look forward to it. Actually, it will be helpful to compare what you are explaining with the code and see to match them and understand.
Yeah, that's
Thank you.
So,
Thank you.
how did we arrive at this? As I told you that initially we began with very simple CNN model. Then we also tried incorporating vision transformer. So when our one success step number 1 we crossed, then we found that no, this like problem demands something more, and so more attention is required. If we applied attentions directly here and in past, it was not giving very good results. So we thought of applying some crisscross attention. So at different scale, what the vision transformer is learning should be also concatenated with a vision transformer learning at a different scale. And we wanted to give further attention to the learned features of vision transformer. That was the idea. So it comes with time that we learn to understand that these are the models. Not only this, in fact, sometimes loss function also helps. Dr. Rakesh might have given you some idea of uh, uh, applying different loss function. How do we modify loss function for domain adaptation? So we initial feature extraction was done, as I told you, by this. Then twin parallel VIT modules were there, given, and then interlace combination of CNN VIT was used. So that helped in a big way. Why? Because then, although there is number of parameters are a little high, but not that high, and it was able to do on all 4 data sets. You could see it was able to do much better than the previous model. In fact, there are a series of models that we developed here. And then we did not stop here. We then went to like totally unseen. That data set is Modi's data or another set data, UCST smoke. But then we took videos and images of GOES satellite, GOES 1617, and with very, very complex scenarios. Like here you can see in hurricane, how do we identify clouds, right? So it was able to perform so very well. We were happy, although false alarm rate was not that good. But then in chimney smoke, it was like we wanted to show that how to see how our model performs on other industrial domains as well. So on chimney smoke, although it was the best model, but still you can see the false alarm rate is very high. Okay. Here also, despite all our efforts, let me tell you that none of the models, although this was doing a little better than the previous model, none of the models were able to perform, to provide better explainability, right? Now coming, so you can see that although TSNE plots were also better, but something still was missing. So we have come out with another model, which was simple. I will first, before talking about these models, I will be, why I'm telling you this? Because you see that we are slowly progressing for model refinement by experimenting. What one of the participants told, that it is very complex. No, it is not complex. We start with very simple models. We keep on adding things and getting idea after looking at the activation function again and again. If you see the activation maps, plot them. By looking them again and again, the idea strikes your mind that, okay, if we put some attention, if we use standard attention, or if we modify the attention a little bit, maybe it will do better. So you can see that now, Sangeeta ji, here we wanted to, like, the complexity is little increased. So we wanted to have a simpler model that can be deployed on edge devices. So here we took 4 transformer and we carried on with the what is known as a, like, we carried on with a convolutional model. So here you can see that it's a residual connection, residual block with convolution that we used here, and then residual block with depth-wise convolution that we used here, and then we again concatenated. So we wanted to see that different, by making use of different types of models. So you must be thinking that I'm only talking about smoke and fire smoke. No, this is just one use case and the journey of the research or model development that I'm telling you, that you start with simple, make it complicated. If it is complicated, complicated means in terms of rich in structure, make it rich in structure. If it is rich, but it is not performing as well as you expected, then you can again think of simplifying or maybe making it more rich. So with the ablation study results, we found that on 4, the lightweight hybrid model with only 0.6 million parameters and little more flops was doing better, I mean, was doing great. And then we tried it on different data sets again. And so you can see that G flops is also good and everything was good. And FAR was quite reasonable here. False alarm rate was significantly reduced, which was a happy moment. I will not go into details of other things that we did cross data validation also. So it was doing very well. Now, what are the future scope? Like, first thing, as a capstone project you can do is data for AI. So data collection and labeling for challenging scenarios. You can do wildfire detection, localization. There are works on localization, but using the current segmentation models that you have studied, can you think of localizing the smoke? Then improving models explainability is a big research question that somebody can take up if they are trying to figure out, trying to find out one good research area. Application can be extended to early detection of harmful industrial gas emissions or chimney smoke. And what you can do is, like project one, data collection from satellite imaging, data labeling, evaluating data quality. Then you can apply a generative AI model for data augmentation. You can do that. Then, or take existing data and apply Gen AI model and see if a model is doing well. Analyze models explainability for different types of network architectures. Using like simple architectures, just look at how explainable the model is. By just taking one CNN layer, one transformer layer, just see what is the explainability. And if you increase the layers, you see the how explainability goes down. So you can use GradCam, Shapley, Line, especially for small size smoke detection. You can choose from the data set small. Only you can select those images which are having small size images, or in general, you can choose anyone. So now question is, somebody was asking IoT security. So one of our students is doing, like, different types of attacks exist. So you can simulate attacks, or if you already, there are a lot of data sets that are available. So you can make use of those data sets where different types of attacks have been performed on in the real IoT network scenario, or have been simulated, making use of say Mininet or any simulation tool. So once you have data, what you can do is that there are several data features, like several data features are there, the number of packets and many things. And so this is normally a one-dimensional vector. Some of them can be strings, some of them can be numerical values. So if there are a string of characters, then you have to tokenize them, right? So then suppose this is a 49 size vector that after tokenization and also one hot encoding, you may be having say 136 dimension vector. Now this 136 dimension vector, you can apply simply ML methods, simple ML methods like SVM, or you can do is that you can first use a data extraction method like data feature extraction method like PCA or autoencoder from deep learning, right? So after you apply autoencoder, then you can send it to say neural network classifier. So that is how you can see that different types of attacks you can see, and or you can find out abnormality. It may not be an attack, but it can be abnormality which could be genuine. All these things can be. So what I hope I have made my point clear, that this is a numerical data, or it is a combination of say number of packets or IP address, or there are various items that are there. So what we do is that we transform this to bigger size vector by either tokenizing them into some tokens or making use of one hot encoding. So this becomes a vector of another form. From here we use feature extraction. It is autoencoder are best suited for that. In case of deep learning, if you want to apply deep learning methods, then once you get the latent space representation from autoencoder, so this is latent space, then you send it to some neural network for classification. It can be LSTM also if the data is temporal, so it can be LSTM as well, right? Is that, have I answered your question? So, Shilpa, I hope this question, yeah, the suggestion I have given will work for your capstone project. Data sets are available. You can think of your capstone project, working on this project only. Could you explain the lightweight aspect of this model? Yes, lightweight. By lightweight, we mean you will have to look at the number of parameters, total parameters, and number of trainable parameters, right? Trainable parameters will also involve a floating point operation. If suppose some parameters you have frozen, suppose some layers you have frozen from a pre-trained model, then those are not trainable parameters, but they will definitely be asking for memory. So for computation as well as for storage, the size of the model is important. So how many parameters are important, and what is the number of operations in one layer is important. So if it is a multi-head attention, and these are neural networks, multi-head attentions require simple multi-layer perceptrons. So number based on the number of nodes, number of computations will be high. So normally vision transformer, although are lightweight if you use less number of units, but then they will not be capturing enough features, because a neuron is the basic memory unit of a model. So if you use very lightweight model, its memory will be small. If you use very large model, its memory requirement will be high. Not only memory requirement, you will also be requiring to do operations every time the input flows from input, the data flows from input layer to output layer. Lot of computations will be required. So your edge device may not be having enough computing power or memory or energy, because if it is drone, it has limited energy. So it will not do anything. So I hope I have made my point clear by lightweight. And can this, all right. Can you please share, if we want to develop a lightweight model, then what should be the thought process in terms of proceeding with the data set, architecture and model development? So Juhi, if we want to develop a lightweight model, think of, see, convolution layers. If you see, if I'm talking about vision models, computer vision based models, right? If it is a simple, like the one I showed here, is a simple neural network based model, right? This one on IoT devices, for IoT this thing. So that is a kind of a single like vector model, or it can be temporal model. So what happens that when you are looking at the data, what kind of data is this? If it is a temporal data, definitely you'll have to think of a sequential model. If it is a spatio-temporal data, then you have to think of a combination of a sequential model like LSTM or transformer unit and a CNN type of unit. So you will have to take both of them. If it is a purely spatial model, like where the images and you have images as the input or arrays and the input as the input, in that case, you can think of CNN primarily. So now when I take a convolution layer, the number of operations are heavy. Even if I choose one filter, the number of operations, multiplication operations that you have to do is huge, right? So generally, you will find that VGG is considered to be one of the best feature extractor. It uses only 3x3 filters. So you can think of increasing the size of the filter only when you think that the model requires, like the data is of that size, that within 3x3 it will not be able to capture the features of the data, right? So you will have to look at the data also, whether my 5x5 filter or 3x3 filter is required. Suppose I require a 7x7 filter and I cannot do without it, right? Do an ablation study, you'd see that, okay, 7x7 is giving better. Then you can think of depth-wise convolution. There are convolution operations also. So depth-wise convolution is lowers down the computational requirement, right? So uh, this capstone project is a very good idea that Rakesh Sanodia ji has given, because this will give you a thinking ground where you will see that, okay, what kind of filter I should use, what kind of neural network should I use. So depending on the data, the neural network, from here, if you want to start your journey in any specific domain, those who are youngsters or who are new to research or new to development, they want to go to industry and they want to develop the entire end-to-end development. How do we do that? So they can start with some pre-trained model, right? And quickly do the experiments and see what happens. So it all depends on the data. And then how do we select model? So my suggestion is look at the literature first. If the models are too complex but very heavy, don't use them in the beginning. Use a small, very simple model, and parallelly increase the complexity of the model by making the structure to be richer. Then lightweight aspect of model further. Lightweight model, as I told you, that lightweight means two important things. And third is its size in terms of MB, how much MB does it occupy? Because it will be ultimately, if it is an edge AI solution, then ultimately it will be floated on, it will be embedded in a edge device. So lightweight means you can reduce as many floating point operations as possible by looking at first thing that comes to your mind is reducing the depth of the network. But if you reduce the depth of the network, you should not be reducing it at the cost of learning deficiency of your model, right? So what happens that we keep the depth of these at a moderate level, and we play with the number of, say, filters in case of CNN, number of transformer units in case of a transformer, the number of multi-head attention within a transformer unit. So if you take more multi-head attention, more complexity. If you take less multi-head attention, but within one multi-head attention, if the number of multi-layer, this perceptron, this MLP layer, number of neurons is very high, that also can cause a lot of computation. So this like various by experiment with, you do your experiment on a small data set and then try how you can do that. So it comes with experience on data and experience on the model's ability to perform. What I suggest to my students is that after every layer, you first find out what it is learning. So take out the features after every layer and visually inspect, like you yourself try to understand what it is learning. Then you will be able to do. Now for there is a lot of research that has gone on, that is going on in the direction of uh, different types of convolution operation, different types of like LSTM, GRU units. So how do we, you just look at the number of floating point operations after like in your model that is required, uh, make changes with respect to number of layers, number of filters, type of filter, type of convolution operation. By filter, I mean type of filter, I mean the type of convolution operation. Just look at that. And then you will be able to perhaps understand better what is meant by um, lightweight model. Now, Juhi Faridi is asking, unfortunately, only very few people are asking. What is the problem? Why can't you ask question? There's no, there's no harm in asking questions if you have. What does it mean to train a model on 10 different data sets? For example, if we train a model on one data set, we usually test it on that same data set. Yes. But if we then train the model on a second data set, the model's weight will change, definitely. And the test accuracy on the first data set might decrease. So how does training on multiple data set works in practice? Good question, Juhi. For this, I believe you have had some session on domain adaptation or knowledge distillation. That is also partly answering this question. Now, let us take, say, three. So let me tell you a continual learning method. You have three data sets, right? All right. So now on this data set, you have trained the model. Okay. What I'll do is that I will now be adding some, this is one method. There are several methods. I will be adding, now this trained model, the saved weights, on this saved model, what I will do is that I will be adding some small amount of data here, and we'll try to fine tune the saved model, right? And there are several types of methods of what are known as incremental class learning or continual learning. There are methods are there. So once it is done, then we slowly increase so that it is learning without forgetting, right? There is a method which is known as learning without forgetting, right? So in between, we again give the experience of the old data. Between several epochs, we again give the experience of the old data. So this keeps on happening. And I would say that a lot of research is going on training on different data sets. Some people also do this thing that they just mix all the three data sets, some part of it, and then, so several methods exist. I suggest you go through the literature on continual learning. Yes, it works in practice. Yes, that is what is happening. Why GPT is becoming so rich? It is because it is learning and without forgetting the knowledge from old data. What is model comparison? Study called, missed the word, please. What is the model? No, it's model compression. Perhaps you are asking model compression. So what, there are methods, there is a library you will find in PyTorch also. Library functions exist that help us prune the model for deployment on real world problems, solving real world problem. Model pruning is a specific method This is also known as quantization methods are there. So suggest you go through the PyTorch library, you'll find that. So Priya Vagmare is asking a question, clearing the concept of lightweight model. Thank you. Could you please suggest few websites, portals from where the weather data can be collected, like temperature, rainfall, solar radiation? Should I look for satellite data or tabular data? So this weather, Shivani Gupta's weather data is a multimodal data. So you can use from satellite, like you can find out Copernicus. Copernicus is a good site where you can find out different types of information. But Indian websites are also there where temperature, rainfall, solar radiation, these things are given. So I have not particularly worked in this area. So it is right now I cannot give you, but perhaps Gaurav can help you find out. I suggest request Gaurav find out if you can help him, help her, Shivani Gupta.
Sure, ma'am. Sure, ma'am. Sure, ma'am. I will
Uh,
help. Yeah.
Study. Ablation study. Sangeeta, ablation study, if perhaps I spoke ablation study, by ablation study we mean whenever you are adding a component, what will happen without that component and what are you gaining with that component, right? And that component structure, by changing the structure of that component, like if I'm adding a convolutional neural network component, or if I'm adding a vision transformer network component, or if I'm adding an attention component, then if I remove that, what is the loss? If I add that, what is the gain? Perhaps you are asking this. Is there any work in your lab, IIITDMJ, on FPGA deployment of AI? Juhi, FPGA is an old story now, right? So if you're thinking of FPGA, don't do that. Think of doing by using Raspberry Pi board or Jetson Nano, because FPGA is I would say it's going obsolete. Yes, we are using Raspberry Pi board. A lot of research is going on in our IIITDMJ also. Particularly, my students have worked on Jetson Nano deployment and Raspberry Pi deployment. Few websites from where IoT-related data for security can be collected. Yes, I agree with you. As you talked about smoke, shall I apply this model to CT diagnosis image? Will it work without loss in data if we reduce the layers? So CT is a different, altogether different domain, right? And that, so it has understood the features of smoke. Smoke features are like, it may change its color, it may change its pattern, it may be thin, it may be thick smoke. So current models are narrow AI models or task-specific models. If you wish to apply it on any other domain, then that model will not work. So what you can do is that for from one domain, a saved model, you can think of fine-tuning that model and testing. So Rajshekhar, this is can be a good capstone project for you, that you use a model that has been trained in, say, one domain, and see how it performs in another domain, and how with different experimentation you can work on the same model, little modified, working in another domain very well. Yeah, abolition study. So can you give roadmap how to implement this to CT images, disease diagnosis, and how give some suggestion in a few pre-processing and few data augmentation techniques. Well, one such data augmentation technique, because you have studied Gen AI, I would suggest use Gen AI method for data augmentation technique. Other methods include adding a very small amount of noise. If it is a vision-based data, small perturbations can be done by adding noise, or you can have crop image, you can have rotated images. So it depends upon the type of data that you have. Augmentation methods also change. Pre-processing requires, normalization is one thing which is required. Data cleaning is required. After manually inspecting, you can apply data cleaning methods also. So first you will have to manually inspect Rajesh Kumarji. Spiking neural networks are also being explored in, I have no idea, spiking neural networks somebody may be using, but it's a huge group of researchers. I have no idea. Can you suggest the model and data set for smart surveillance for road safety? Because I have not worked in this area, I do not have uh, road safety smart surveillance because it's a computer vision problem. The models that I discussed, you can think of applying similar models for smart surveillance. They also work very well on, so we have also tested these models on video. So they work very well on videos as well. So you can think of creating similar models for model testing for overload violation. Now see, rest of the thing is smart surveillance for road safety, like detecting real-time helmet and overload violation. If you're looking at helmet detection, then models like YOLO are better suited, because there you also be localizing them, and overload violation also will be a localization model. So my suggestion is start experimenting with YOLO first, the current version of YOLO. Few websites from where IoT related data for security can be collected. Request Gaurav, can you please note down this? We will tell them the websites. Can you suggest
Okay,
few
ma'am. Sure.
websites?
Ma'am,
Can you
sure.
please explain about the idea about different uh, domain implementation, which you said? Uh, for me, bit confusing. Okay, Rajesh ji, may I ask Gaurav, is Dr. Rakesh Sanodia here, available here? Is Dr. Sanodia there? Or is he attending? Gaurav, can you see
Actually,
his?
ma'am, he has joined, but I don't know whether he's on the system, but I'll check with him.
Yeah, he's there, but I don't know. So I just wanted to know, Gaurav, I think he has taken a session on domain adaptation. Rajesh ji, may I request you to please go through this topic on domain adaptation, how knowledge transfer can be given, or knowledge distillation methods can be done. So can I apply image captioning idea along with this using transformer and explainable AI for diagnosis? Yes, yes, you can do that. Image captioning, yes, this is going on. Yes, that is very much possible. So what for that you will have to do what? You will have to do a parallel LSTM model also run. So whatever is coming from say transformer, or you will have to also make a parallel like captioning model that works in sync with your detection model, right? So that will be there. Okay, Rajesh ji. Considering to work with data which are both spatial and time dependent, can you please outline the approach to take or to create a good architecture? So, which is spatio-temporal data, and that is what I just spoke with Rajesh ji also. that what we do is that we normally take inputs, extract features, and then I've seen that people use parallel models. Like one is one part of it, one component of it then goes to say a caption, image captioning. The other part goes to say diagnosis, right? In case of CT images. In case of any spatio-temporal data, what we do is that we make use of a good combination of a sequential model like LSTM. So, and spatial model, like suppose you want to, in each frame of a video, you want to extract features. So if there's a spatial feature that you extract, and then you also pass LSTM, it through LSTM, so that it remembers the context also. So what we can do is that we can use parallel models, you can in sync with the CNN, you can do that, and we can have a independent discussion if you want to have a one-to-one discussion on this, Sangeeta ji. Arpana is asking if collected earthquake data of India and want to predict the future earthquake in various regions on India, what will be the best model? Arpana, there is no best model. For that data set, the comprehensibility of the data set is important, right? So first is the data set should be comprehensive, and future events. You know that with the changing weather, global warming, unpredictability is increasing, right? Earthquakes are still one of the, which we call it a kind of problem. We call such problems as grand challenges. These are known as grand challenges. So these problems are such that because we have not yet understood the problem statement itself very well, and therefore finding out solution itself is a grand challenge. So these problems are known as grand challenge problems. Okay, can you please guide me, as I want to work on natural disaster prediction, out of which I do thought about taking earthquake data of Bhukosh website. Okay. Arpana, you can think of like this landslides are increasing. So you can make use of a temporal data from satellite and think of like what could be, how the pattern is changing. So there is a future of landslide. So that is a more like easier than earthquake. Earthquake is a much more grand challenge kind of problem. Few websites from where IIT-related data. Can you suggest few websites? Ashutosh Saurav. Thank you, Ashutosh. He has given some websites. I don't know what kind of website is this. Thingsboard.io, webbylab.com, blog.iot data. Oh, thank you so very much, Ashutosh. Thanks for helping. Can you share the medical images data set if known? Gaurav?
Yes,
I
ma'am.
think you have worked on a medical image data set last in your coursework.
Yes, ma'am. Actually, it was lung sound
So
detection dataset.
you can share
So,
with him. Yeah, you can
yes,
share.
sure.
I think I should stop here because although I was having a long set of image project ideas that our students have this, what I wanted to convey is that let us begin with very simple problem, and then let us look at the data around us. If the data is available, then how that can be done, and then try doing just one example from end to end. Whether flops are high, whether flops are low, don't worry about it. Its performance should be coming great. Once performance comes great, then we think of like playing with the components so that performance can be retained and the model complexity can be reduced. So my suggestion is like think of an topic and our researchers here will help you. If you are not able to get data, will try their best to help you. I cannot say that data is available in every domain. So Gaurav is saying second session, afternoon session is about data sets. So it will be helpful for you all. Thank you so very much, Gaurav. That is all from my side. And in all my research domains, undergraduate students are making wonders. So we have currently 2 interns which are currently in my lab. They're undergraduates apart from other postgraduate and PhDs. So they are also contributing a lot. And with many undergraduates, we have filed patents, we have written research papers. So if you are undergraduate, you can also think of collaborating with seniors here in this group so that you can think of writing patents, research papers, and building useful solutions above all. Thank you so very much. Have a great
Thank you. Thank you, ma'am. Thank you for your session, ma'am.
thank you.
Thank you, ma'am.